Friday we have, wait.
Tomorrow's Friday.
Yep.
Okay, so we're going to look at cylinders and cones and begin by identifying the parts of right cylinders and cones. Remember, we're always going to be working with right solid figures. We're going to find lateral area, surface area, and volume again. All of these formulas are on your volume sheet, so you have that available to you. A cylinder is a solid figure having congruent circular bases and parallel planes. In fact, you have a picture of a cylinder in your packet. Notice the bases here are circles. You can see them better in your packet. The bases are circles, and they're in a parallel planes. All right, so let's look at the parts of the circular cylinder. You have your two bases. The axis of the cylinder is a segment that connects the center points. It's drawn on your picture. That's the axis of the cylinder. And the altitude of the cylinder or the height of the cylinder. Altitude and height refer to the same thing. And that is the perpendicular segment from a point in one base to a point in the other. The axis of the cylinder could represent the height, but the outer edge could also represent the height of that cylinder. Now, when we're talking about the base, remember in our formulas we had perimeter of the base. Well, the circumference of a circle and the perimeter of the circle are the same thing. And the formula for circumference of a circle, we looked at this on Tuesday. Your warm-up was 2 pi r. And the area of a circle is pi r squared. So those are pretty easy to find. Let's go to the next page. Here are your formulas. And it compares the formulas that we had for the prisms to cylinders. A right prism, remember the lateral area was perimeter times height, but for a right cylinder, it's perimeter, but in this case, circumference times the height. 2 pi r times h. Parker?
On the quiz or worksheets, do you want us to just leave pi by itself?
Leave it in pi. Leave your answer in pi. Don't try to multiply it out. So your answer will have pi in it. You'll leave it as pi, not multiply by 3.14.
Oh.
All right, when we're looking at surface area for a right prism, it was the lateral area plus twice the area of the bases. And it's the same principle for a right cylinder. It's the lateral area, which is the circumference times the height, plus 2 times the area of the bases. That way you're getting the top base and the bottom base. It's a closed, solid figure. And volume for a right prism was base times height, the area of the base times the height, and it's the same thing for the right cylinder. It's the area of the base, pi r squared, times the height. So let's look at this example that we have here. A cylinder has a 5 centimeter radius and a 6 centimeter height. So I'm going to go ahead and label the radius and the height. And we want to find lateral area, surface area, and volume. And again, this tells us, leave your answers, leave pi in your answer. Don't try to multiply it out. Makes it a little bit easier for you. So we said that lateral area is perimeter times height. In this case, perimeter is circumference, which is 2 pi r. So lateral area is twice pi times the radius, or 10 pi centimeters squared. Area is always squared. Surface area, thank you, is the lateral area plus twice the area of the bases. So we've already found lateral area. That was 10 pi. The area of the base is pi times the radius squared. or 25 pi. So 10 pi plus 2 times 25 pi is 60 pi centimeters squared. Yes, ma'am.
Is this on the right cylinder?
Yes.
Okay.
Page?
Weren't we supposed to multiply times 6 for the lateral area? Because the height is 6.
Oh, you are right. Thank you, thank you, thank you. I forgot to multiply. Thank you for catching that. So it was 10 pi times 10, or 100.
What? It's times 6.
Thank you.
Let's make a new video.
Oh, wait, we're recording. Yeah.
Thank you for catching that.
Okay.
Okay, so I have to change this to 60. So that makes this 110 pi centimeters squared.
Can you leave that up there for a second?
Let's look at volume. We said volume is the area of the base times the height. In this case, the area of the base is pi r squared, which we found to be 25 pi. And what was the height?
6.
This time I get it right. So this is equal to 150 pi centimeters cubed for the volume of that right cylinder. The volume's easy. You've already found the area of the base. You
So we
just
did all
multiply it by the height. All right, let's look at the cones. A cone is a solid figure with one vertex, and it has a circular base. We haven't talked about pyramids yet, but a pyramid's going to have a different kind of base.
It looks like an angle.
A cone has a circular base. It has one vertex, one base. Everything we've looked at before has two bases. This just has one base. One base, one vertex. And the altitude is the segment from the vertex perpendicular to the base. So Clarissa, in this case, the altitude goes from the vertex to the center of the base, and it's perpendicular. And the edge is called the slant height. This would be a slant height, or this could be a slant height on the outside of the cone. The altitude would be measured inside the cone. That gives you a true height. Okay? Yes, ma'am.
So is the slant height the same height as the altitude?
No, it will not be the same. Notice we have a right triangle that's formed from the altitude, the radius, that's a good question, and the slant height. So if you know the slant height and the radius, you can find the altitude. Or if you know the altitude and the radius, you can find the slant height using our right triangle. So you will be using right triangles in dealing with cones. Let's look at our formulas again. We're not going to worry about the regular pyramids right now. We'll just look at the formulas for cone. For the lateral area, the formula, you have this in your notes, is pi RL. Pi RL, pi times the radius times the lateral length, the slant length, the lateral length, not the altitude. Chloe?
What are we going to be able to use on the semester exam?
We're not going to talk about semester exam right now. Right now we're talking
But it's
about
only her.
solids. Okay, so this L is the slant height or the lateral height, not the altitude. So it's important to keep these formulas in front of you so you don't get it mixed up.
Will we have the sheet?
You may use the sheet. Lauren, turn around. Surface area is the lateral area plus the area of the base, pi r squared. We only have one base this time. So it's the lateral area plus the area of the base. And then the volume is 1/3 the area of the base times the height. Pi r squared h over 3, or 1/3 pi r squared h. So these are the formulas that we're going to be using. You can keep these formulas in front of you. You may use a calculator on your homework. At the end of the year, some of these numbers get a little big, so I'm letting you use a calculator. So let's look at the problem that we have here. A cone has a radius of 6 centimeters. And an altitude of 9 centimeters. We want to find the lateral area, surface area, and volume. What do I need to find the lateral area? We need the slant height. How can I find the slant height? Pythagorean theorem. All right, so we know that the slant height, or L squared is going to be equal to 6 squared plus 9 squared. 36 plus 81 equals L squared. 7, 3, and 8 is 11. So L equals 3 square roots of 13. Thank you. It's okay to have square roots in your answer. If we're going to find the lateral area, we've got the formula that says it is pi r L. What's the radius, Chloe? 6. So we're going to have pi times 6 times 3 square roots of 13. Remember, you can't multiply underneath the radical unless both things are under the radical. So we have 18 square roots of 13 pi centimeters squared. That is your lateral area.
Wait,
Wait, I thought you could multiply 6 and 3.
You multiply what's outside. You can't add them, but you can multiply them. Okay, it's like if you had 2 times 3x, you could multiply the 2, but you couldn't add those together. All right, now surface area, we've already got half our work done for surface area. Because surface area is the lateral area, pi r L, plus the area of the base, which is pi r squared. So we've already got our surface area. The radius is 6, so we're going to have 36 pi.
wait.
And this
Surface
is
area?
centimeters squared. Pardon?
This is surface area?
Surface area. 18 pi square roots of 3 plus 36 pi centimeters squared. And then
The
volume,
first one was lateral area?
first one was lateral area.
Why wouldn't you keep pi with 18 and square root?
You could.
Oh, you did, okay, I didn't see that, sorry.
You can't like add higher or something together.
If it was 18 pi plus 36 pi, you could add those two together, but because of that square root of 3, we can't combine them. You could factor pi out, but that wouldn't be much help right now. All right, and volume we said is 1/3 pi r squared times the height. Did we find pi r squared?
Yes.
That was,
Do we use pi because the circle like never has an endpoint?
there's a ratio that pi always comes up with every circle, and I don't know all the exact history of that, but it does have to do with radius and circle. And the height is 9. So if we want to, we can go ahead and divide that. And 12 times 9, which is 18, 108 pi centimeters cubed. Any questions? Okay, on the worksheet that I'm fixing to give to you, I want you to do your work on a separate sheet of paper, and you are to do numbers 1 through 15. You don't have to do them all. Shh. You need to do numbers 1 through 15 on the paper in separate sheet.